How massive do black holes get? At the moment, sizable examples are known that were formed as a result of the collapse of huge stars, a process that could theoretically give rise to black holes of enormous mass. Located at the center of most, if not all galaxies, are supermassive black holes with a mass of millions or billions of times greater than the Sun's mass. For example, in the center of our galaxy is Sagittarius A, whose mass amounts to about 4.5 million suns. Of the known black holes, the one with the smallest mass is only 5 times more massive than our star, but 100,000 times more compact. The diameter of some black holes is no more than the expanse of a large city, but the weight of such a munchkin is like 5,000 suns. The radius of others is comparable to the radius of the Earth, but their mass is 6 million times greater than that of our planet. It simply gets lost against the background of, say, the hole in the center of the Messier 60 galaxy, which has a mass of 4.7 billion suns. The class of ultramassive black holes begins at around this mass, the largest of which are made up of even as many as 4.5 billion suns. But even they seem to be cosmic infants. Currently, the largest known black hole is the TON 618 quasar, which has the mass of 66 billion times the mass of the Sun. It is located near the North Pole of the galaxy, in the constellation of Canis Venatici, the hunting dogs. The TON 618 quasar is believed to have an accretion disk of hot gas orbiting the giant black hole at the center of the galaxy. The quasar is estimated to be 3.18 gigaparsec, or 10.37 billion light-years away. The emission lines in the spectrum of TON 618 are usually wide, which tells us that the gas in the accretion disk is moving at very high speed, about 7,000 kilometers per second. The galaxy, in the center of which the quasar is located, is not visible from Earth due to the brightness of the quasar itself. Its absolute stellar magnitude is 140 trillion times greater than that of the Sun. It is precisely because of this that the exact mass cannot be determined. What can't be said about this new challenger, which has the name HOLM 15A? Holmberg 15A is a Type CD supergiant elliptical galaxy that is located in the Abell 85 galaxy cluster in the constellation of Cetus, about 700 million light-years from the Sun. The galaxy of Type CD is a subclass of the giant elliptical galaxies of morphological class D. Such galaxies have large stellar halos and can be found near the centers of some large galaxy clusters. They are often considered as potentially the largest representative of galaxies in the universe. Holmberg 15A was discovered in 1937 by Erich Holmberg. The galaxy became famous after it was announced that it had the largest of all observed galactic cores, sprawling about 15,000 light-years in expanse. But then the discovery was refuted. Now HOLM 15A is taking the lead again. The fact is that the Abell 85 cluster has its velocity dispersion in a dark halo of about 750 kilometers per second, which can only be explained by the presence of a supermassive black hole with an immense mass of at least 170 billion solar masses. although the halo of dark matter is not subject to this kind of scaling. But the evolution of a black hole and dark matter has nothing to do with baryonic matter. Notably, among known objects, this is one with the heaviest supermassive black holes. This classic case tells us that the main component of the galactic core is a supermassive black hole with a mass of about 40 billion solar masses and a radius of about 790 astronomical units. By comparison, Pluto is located at a distance of about 39.5 astronomical units away. However, according to the data, the gamma radiation from the object is so extensive that some researchers estimate HOLM 15A at 310 billion solar masses. How is it possible? Let's try to figure out this galactic mystery. It became obvious from observation that the distribution of stellar orbits was shifting more and more towards tangential motion inside the core. However, the displacement is less than in that of other elliptical galaxies with cores. This tells us that in earlier time there was a merging of galaxies with black holes. Astronomers have detected that the observed magnitude of tangential anisotropy and the shape of the light profile are consistent with a formation scenario where HOLM 15A is remnant of the merger of two supergiant black holes. And now the masses of black holes in galaxies with cores, including HOLM 15A, are proportionally scaled inversely with the brightness of the star's central surface and the density of the mass, respectively. That is precisely why black hole HOLM 15A has taken the position as one of the largest and hungriest supermassive black holes. The new estimate of its size is from 40 to 310 billion solar masses, and its rate of accretion of matter is estimated from about 8,000 to 45,000 times more massive than the black hole in the center of the Milky Way. If the black hole in our galaxy were to accumulate that much matter, it would have to mercilessly swallow 2/3 of all the stars in the Milky Way. Further research will reveal the secrets of this object, but no matter what, the HOLM 15A black hole is the heaviest among all that have been discovered thus far.